Okay, well, good day to you all. Hope you're all staying safe, and thanks very much for joining us for the Connected Oilfield video conference. The conference is going to be held in two sessions. You're going to need to have access details for both, but all of you delegates have registered for both, so you should get emails shortly before with that access information. But just keep an eye out for that, and if it doesn't come through, check your spam folder, etc., etc. But there really shouldn't be any problems. Now, as the presentations are delivered, to the right-hand side of the screen, you'll have a sidebar with a questions option at the top, and you can submit your questions as the speakers are making their presentations. Please don't wait until the Q&A, otherwise we'll have a massive influx and be impossible to cope with. And we'll put your questions, do our best to put your questions to the speakers, but there are a lot of you out there, so please be patient with us. With that, I want to get straight into it because we've got a lot to get through. So I'm going to introduce Mark Lambert, who is joining us from Kratos. He is the president of the UK business unit, and he provides a wide range of software and hardware solutions for monitoring and controlling satellites and ground systems. Mark has got 30 years experience in senior roles in the satellite industry, infrastructure and wider communications technology consulting. So very much a specialist in these subjects. Mark, can I hand it over to you?
Thank you very much, Paul. It's a pleasure to be here today and to speak. As Paul was saying, Kratos is involved in many different areas. Some of these little icons down the left-hand side of my first slide hint at some of them. Ranges from defence through jet engines through to that one at the top, which represents space. Space is actually the largest of our activities, and particularly ground systems. My ground systems for satellite communication. My topic today, as it says on this slide, is the connected oil field and the cloud. Well, the connected oil field in particular, we're going to be focusing on satellite communications. That's the theme of this particular conference, oil fields related to satellite communications. The cloud, many people might be thinking, well, we've used cloud in the oil and gas industry for many years. We know all about how to use cloud infrastructure to help us with processing, etc. That's not the theme of my presentation. The theme of this presentation is how we use the cloud to implement our satellite communications and how we can use that flexibility of the cloud to give us a really flexible solution for implementing satellite communications, and particularly the ground systems. Before I get into the detail of that, I just want to give a very, very quick recap of where we've come from in the world of satellite communications. Back in the beginning, we talked about bent pipe satellites, by which we meant that we transmitted a whole load of carriers up to the satellite. It basically acted as a mirror, turned them around and transmitted them straight back down to Earth again. And then as we became a little more sophisticated, we developed so-called high throughput satellites, which made use of spot beams to give more concentrated, higher throughput capacity to different areas of the target area on the Earth. And so effectively, we transmitted up those carriers and they came down in a slightly different combination, slightly different directions to implement those spot beams on the Earth's surface. Now we are entering a new era, that of dynamic payloads. Dynamic payloads, and particularly if you could see the animated version of this slide, effectively the payload on the satellite, rather than just reflecting the incoming carriers back down to Earth, is constantly changing in the way that this parcel sorting machine is able to constantly change the way those parcels are routed across the bed, able to frequently and constantly change the routes through the satellite, how it handles the data passing through the satellite to route data to different spot beams, etc., in a very flexible manner. If we're going to be launching these dynamic payloads on satellite, we're going to need dynamic solutions in our ground systems. Kratos has a huge experience in implementing ground systems. We build this sort of thing all day long. This particular antenna is a 12-meter KU band system, but it could be Ka band, it could be any of the frequency ranges. That's not particularly important. Kratos doesn't focus on implementing the data processing systems, the VSAT systems. Instead, we specialize in all of the areas that go around those data processing or VSAT systems to make sure that they're working effectively, whether that is implementing those antenna systems. Particular one on the top left is a Ka band system that was installed in Asia Pacific for Pacific, a new operator down there recently. And all of the other elements of making sure that satellite communications can run smoothly. So we believe that we are experts or an authority on the use of HTS systems, high throughput satellites. So what is virtual ground? What is the use of the cloud to implement ground systems? Well, we're not doing away with those satellite antennas or dishes that we need to communicate directly with the satellite. But what we are doing is digitizing all of the traffic to and from those antennae. So the received signal would be immediately digitized, passed into the cloud. The signal that is to be transmitted is received at the antenna as an IP stream and then converted back to analog radio frequency to be transmitted towards the satellite. And so we're transitioning these ground systems into the cloud. All of the data processing systems, whether it's the modems or frequency converters or channelizers, all of that becomes a series of virtual network functions that can be housed in a public cloud or in a private cloud, a local data center, etc. And that gives a huge amount of flexibility. We can orchestrate using standardized tools these different virtual network functions in the cloud or in the data processing server to create different services on the fly just as they are required, and then to do away with them again just as quickly when the need goes away. And so if we look at how that can be applied to the digital oil field, and I'm just trying to seed some questions for the upcoming Q&A session at the end of the presentations. But some ideas here on how it can be used in the digital oil field are the ability to spin services up and down to suit operational requirements. So if we are in exploration mode and we're creating huge amounts of seismic data, that can be, a service can be set up to trunk that back for analysis. And when that current capture of seismic data has been trunked back to the processing center, that service can be taken down again. So we've got the ability to create short-term, high-capacity links as services. It also lends itself to a more shared infrastructure, and shared infrastructure allows the ability to bring costs moving into the world of OPEX rather than CAPEX, and hence putting them in line with revenues being earned rather than needing huge upfront investment. It's an option. It's not necessary for every system. It also brings great cybersecurity benefits, and maybe there will be some questions in that area. I'll wait until the Q&A to elaborate on it, but it does offer some great advances in the area of cybersecurity. So those were the few slides that I wanted to use to introduce the topic of virtual ground systems and using cloud to provide ground infrastructure for satellite communications and how it can be applied to the digital oil field. There are some further slides on this subject in my deck. Those will be available in the PDF version of the presentation, which Paul will be putting onto the website. So if there is further interest, please take a look there. This is not science fiction. This is something that we are implementing today. So it's very much the future as Kratos sees it and as Kratos are implementing it. So please, looking forward to your questions in the Q&A session. But for now, I'll hand back to Paul. Over to you, Paul.
Thanks, Mark. Very good. Okay, can I ask Alex in the room, Alex Besen? Alex is the founder and CEO of the Besen Group. He provides strategic advisory, business development, market research and training services in the mobile data industry. He's got over 26 years of hands-on experience in the mobile industry, working for operators and vendors in North America and Europe in a variety of roles. His references include world-class companies like Ericsson, Globalstar, Nokia, Orange, Panasonic, T-Mobile US and Turk Telecom. So with that qualification, let me hand you over to Alex, and please take the floor, Alex.
Thank you, Paul, for the invitation and the introduction. Yes, just wanted to share a quick background here on the company. If you're not familiar with our industry, mobile data, we focus on the 5G private networks and satellite industry as well. We work with multiple different clients all around the world, including operators, enterprises, MVNOs, vendors, as well as the financial institutions that include the hedge funds, private equity firms, and investment banks. And we've been working in the private LTE space now for the past 4 years. We offer strategic advisory, training, market research, as well as business development. And in terms of our market research services, that include some case studies that are very exclusive to the industry. And I will say that we are the only one in the US today who publishes the private LTE case studies on the different vertical segments. And then we also developed the industry first private LTE business case tools on a CBRS spectrum. And we also customize our tools based on the different use cases. We also offer training services and regarding private LTE, we have a half-day or full-day seminar available as well. And we can also customize our seminars based on the client's requirements. So in terms of defining a private network, we define it as a dedicated network for consumers, businesses, and Internet of Things. Private network or private LTE network can be based on license, in-license, or shared spectrum. Shared spectrum, again, in the US, we refer as for CBRS, but it can be, different in other geographies as well. We estimate that the global private network market to grow annual combined growth rate of about 27%. That's the availability of the new spectrum bands coming up, as well as the maturity of the LTE ecosystem. So this we predict is going to account about $8.5 billion by end of 2025. We think the key characteristic of a private LTE network are mobility, security, reliability, coverage, and low latency. Most of our customers, they compare the private LTE network to Wi-Fi deployment, and then that's the one key reason they choose, or they make their decision to go with the private LTE network, right? Because of these key characteristics. Today we're going to focus on the oil rig. We believe the benefits for the private LTE networks are tremendous to deploy such a network, offering video surveillance and analytics, improve operations and living conditions, enhancing remote operations capabilities, ability to manage multiple applications. Some simple use cases, we believe from the template that we would like to share with you, that include the track and trace containers, predictive maintenance by monitoring vibrations in the central machinery, assisted maintenance, monitoring, condition of a construction, reducing carbon dioxide emissions, automatic ordering of spare parts, optimizing and securing lift operations. In terms of their business model, there are, I will say, multiple of them. For today's presentation, we're going to share only 3. So this is a standalone private LTE network. So there is no access to the public network there. So just a private LTE core. The second one, the private LTE network has a roaming feature, the capability to the public network, right? So it will be able to do that. And the third business model, having a subscriber on the public network, accessing the private LTE network, okay, with all the features and benefits. So we look at 2 different scenarios today. We're going to look at one scenario of deploying the private LTE network as a macro tower on the oil rig, okay? So it can either be done by the oil company or by the service company. So in our scenario, we assume that there is one company who's going to deploy the service, the tower deployment and management. So a good example here is from, again, template. They have deployed this 4G private LTE network in the Gulf of Mexico on a macro tower basis. And if you look at the coverage of deploying a macro tower based private LTE network, it gives you a coverage about 80% to 90%, okay, with high throughput, right? There you see we have there are 4 different decks there. The upper deck, it has a great coverage. Upper module deck, has good coverage but has some lost coverage as well. The module deck and the stellar decks, they are losing coverage requirements there. So as you go down below, you're losing coverage there. But again, this is a one single antenna setup on the platform, and then we will look at the second scenario based on small cells. Okay, on the small cells, they can be deployed. We have, this is based on Evo Packet Core EPC. We looked at it in terms of the CBRS spectrum here, and for the US market, and then we looked at the each different element of HSS, MME, serving gateway, PDN gateway, and the functionality and pricing. We've interviewed a couple of EPC vendors, and then calculated our own business case comparison here for today's presentation. So we made some assumptions in terms of the size of the oil rig. We said it's 400 feet by 250 feet. We have about 150 of crew on site. Assumptions, we said the fiber backhaul is already available. We can also make the assumption the satellite backhaul is already available as well, but we didn't account that into our calculation. Roaming is available to our roaming partner. So here we are looking at the 2 different scenario deployment for private LTE network in oil rig. Scenario 1 is based on the macro tower, and scenario 2 is based on number of small cells. We calculated that the oil rig needs 32 small cells in order to offer 100% coverage. Right? Of course, that comes with the capex of $182,000. And the OPEX is about $180,000 for the scenario 2, and then total cost of ownership is about $262,000 for the small cell based deployment of a private LTE network. So you see the price difference there. Of course, it all depends again on the oil rigs geographic location, and understanding what will be the the backhaul capabilities are in that area. So we are working on our first oil field private LTE network today in the US market. And but more information on our company, on our private LTE services, please visit our website. Thank you for the invitation again.
Okay, thank you very much, Alex. Next we have Jean-Michel Rouylou, who's Head of Enterprise and Broadband at ST Engineering iDirect. He's there responsible for the company's strategy for enterprise, focusing on energy, banking, and consumer broadband. He spent 3 years as an executive VP at ITC Global, helping to establish a KU-band network for the maritime market, and 20 years at Schlumberger in Aberdeen. So welcome to the stage, Jean-Michel. I'll just bring up your presentation. And here we are.
Good morning, afternoon, evening, wherever you are in the world. I am Jean-Michel Rouylou from ST Engineering iDirect, where I look after the enterprise and broadband go-to-market strategy and product fit. First, let me thank Century 21 and especially Paul for setting this up. Webinar has become my new form of travel, and so I'm very grateful for those who spend the time and the effort to arrange them. Today, I want to talk to you about VSAT and LTE and how the two wireless technologies can complement each other for the oil and gas community. Combining the two technologies is a way to increase resilience and availability, to offer continuous connectivity while mobile or remote, to enhance performances by using high-speed data access of LTE whenever available, and to reduce uptakes by reducing management and maintenance cost of the combined network. For that, we'll go through two use cases to demonstrate how VSAT and LTE can complement each other. The first one is extending a private LTE network to a deep offshore platform. And the second is looking at how the connectivity of an OSV boat can change during its journey. Before we go into each use case, it may be good to have a brief overview of private LTE, as this may still be new to some of you. As you can see on the Gartner hype cycle for wireless network, private LTE is almost at the top of the hype. Alongside 5G, vRAN, universal CPE, private LTE is getting more and more attention from network service provider and mobile network operators. Private LTE is simply said a dedicated LTE infrastructure for a closed user group. This group could be consumers, employees, or even IoT sensors. It could be installed and managed as an extension of an MNO public LTE, or as a dedicated infrastructure of a service provider, as we have plenty of examples in the North Sea and the Gulf of Mexico, or even designed, installed, and operated by the IT organization of the enterprise. Its small form factors bring flexibility to scale it, leveraging on virtualized architecture. It reduces installation and operation cost. It can use license and unlicensed on shared spectrum depending on local regulation. What could that bring you? The initial requirement is coverage, extending traditional Wi-Fi network to larger area or where Wi-Fi performance is impaired by local environments, steel, houses, blockage. Second is to enhance control of who accesses the network. Private LTE needs each and every user to have a SIM or an eSIM that can only be issued by the manager of the private LTE. Each SIM will have different level of access of services. Removing access to the network can simply be done by canceling the SIM. Multiple RAN and built-in redundancy of LTE infrastructure will provide highly resilient environment for mission-critical applications. With the explosion of IoT sensor and gateway data, LTE provides a standardized secure environment to deploy a large number of IoT sensors. And last but not least, costs are predictable, as there is no pay-per-use scheme found in commercial LTE elsewhere. So why is private LTE getting some traction today? Simply because a number of stars have aligned. Liberalization of some shared spectrum and better use of unlicensed spectrum. MNO, using their knowledge of public LTE, start offering semi-private LTE, shortening the time to market. The hardware vendors, through Alliance, are pushing the technology, seeing a way to keep selling their LTE equipment. And finally, open standards like Open RAN and virtualization like VEPC and eSIMs make it more cost-effective to build a private LTE network. Oil and gas operates very often out of reach of traditional terrestrial network, and satellite has been and it always is the only way to connect to the rest of the world. In this example, you see that a private LTE has been built on a platform to provide a secure, highly reliable infrastructure for the crew for the IoT sensors. It also provides a reliable push-to-talk services on board and a secure access to third parties that are operating on the platform. In this environment, ST iDirect IQ LTE modem will simplify the integration of VSAT backhaul to your LTE network. Using iDirect L2OS, layer 2 over satellite technology, you can set up private LTE backhaul VLAN. At the same time, use traditional VLAN for corporate connectivity. A single device can be used to provide traditional corporate network connectivity and extension offshore of the company private LTE. Another area where VSAT and LTE will benefit your industry is when you have to use hybrid network. In this environment, you need to connect two different types of wireless technology to improve coverages or performances. There is multiple ways of leveraging the wireless technology. You can use one to back up the other, or you can use traffic differentiation to use the most efficient network to carry one specific type of traffic, like voice over LTE rather than over satellite. You can take benefits or advantage of some specificity of one of the wireless technology. I'm thinking about multicast with VSAT, for example. And definitely you are going to extend the coverage of the LTE network. As you can see in this example, an OSV boat will be equipped with the ST iDirect LTE using three wireless technology: satellite, Wi-Fi, and LTE. While in port, the ship will be connected to the local Wi-Fi network. Going to sea, it will start using LTE while near shore, and will switch to VSAT when too far from the coast. All these network changes are done automatically and transparently by our equipment during the boat journey. No human intervention, no decision-taking processes are needed for the boat to seamlessly move from one network to another. So here it is, this beautiful ST-IQ LTE modem that was used in both cases. We are capitalizing on the maturity of our Evolution platform to add LTE connectivity from one of the leading LTE modem vendors, Cradlepoint, to that state-of-the-art VSAT modem. I'm not going to go into the details of the technology nor the modem's characteristics. Just wanted to let you know that this is available and this can be deployed on any Evolution network today. A quick word about ST Engineering iDirect. Following the merger of iDirect and NewTek, we are continuing to innovate on performances, efficiency, and scale, bringing together the best of both worlds. We'll provide you with the right technology at the right cost model. We strive to exceed our customer expectation and follow you in the technology changes that are coming, like cloud, 5G, virtualization, and so much more. And to conclude, a quick reminder of what we do at ST Engineering. Operational support, implementation, training and certification, manufacturing, developing component. But we also provide managed services. We help you do the system integration, and we have a consultancy services that can help you design and size the network you want to build. And last, we also do some terminal integration, either on the mobile world, being maritime or aero, or on the land by building a gateway. So thank you for your time, and I'm looking forward to answer your questions.
Very good.
Before we go, just wanted to share with you my stay-at-home outfit and where I work and record that presentation. I didn't want to have you to see me all the time, so that's why I'm just doing it at the last slide. Thank you again, and looking forward to hear you.
Thanks, Jean-Michel. I think your reference to webinar as being the new form of travel is absolutely spot on. I will be quoting you on that going forward. Thanks very much, and thanks, James, for joining us. Just to quickly introduce James. James is a commercial leader with a very strong background in the oil and gas, energy, maritime, enterprise, media, and government verticals across the US, EMEA, and the CIS. He's held executive positions in Lexmark, Nortel, Arqiva, and served as chairman of the World Teleport Association for over 5 years. So I'm just going to bring up James's presentation now.
Thanks, Paul. Hi, everybody. This is a new experience for me. I know some of you will know me. I'm an excellent presenter on the real stage. See how I get on the virtual stage. I have 10 minutes to give you a quick update on the digital progress that I see from our customers' perspective, and some of the insight into how Speedcast is enabling their digital initiatives. So before I start, just a very quick reminder of the types of things that Speedcast does in the oil field, both offshore and onshore. You can see a variety of different IT and networking applications there. And if any of you want to find out more about those, please get in touch and we can organize a meeting with one of the team. So on to the agenda. The next 4 or 5 slides, I'm going to really skip quickly through what I call digital growth vectors. They're not from Gartner, they're from James Trevelyan. So they're my interpretation based on the conversations that I have with our customers. And obviously, data collection is the starting point. There are literally millions of lines of data spewing out of a digital rig these days, and just about every different and possible aspect of a rig's performance, data is now being recorded. And I guess the great hope is that this data can inform, encourage, and safer and a better set of choices. So whoever moved my slides, if they could just leave them where they are, thank you. You can see from this one small example on this slide, one example of where the data is coming from. Today's wired drill pipe can draw more data than its predecessor by a factor of 2,000 or 3,000. So, just in one single application, you can see, where all this data is coming from. And of course, how we analyze the data is pretty critical because it's useless otherwise. So this is an area that customers are really focusing on. They're basically working with data scientists, and the objective is to write kind of pre-built algorithms which are capable of doing any number of things. I guess the holy grail is that these applications can help the rig manager predict what's going to happen on his rig. But as I say, there are many different applications, and without the science behind the data, it's a little bit meaningless. And of course, the cloud itself is crunching most of this data, so it's an important part of the overall ecosystem. Artificial intelligence, again, another huge subject. It takes many forms, and some of you will know about augmented reality and virtual reality. You know, the fundamental behind this is that these sorts of technologies are basically making assets smarter. You can see on the screen there, hopefully, how one driller is using a digital twin, which is basically a virtual representation of a rig. And they use these digital twins to test out operational procedures and changes in a safe way, to predict failures, and essentially test the outcome of any kind of future work that they're doing or planning to do on the rig without kind of getting their hands dirty, so to speak. Automation, you know, the oil field is just becoming more and more automated, you know, every year, basically. The use of robots like Spot the Dog, who kind of walk around and sniff for gas leaks or measure the sound that's coming out of machinery to test for abnormalities, are becoming more and more commonplace. They're not exposed to any of the social distancing regulations that we currently have to adhere to. They don't have to go into quarantine. So this is something that, you know, COVID-19 will probably expedite. But, you know, automation isn't just about robots. If you think about the drill floor on a rig, yeah, preventing, you know, unnecessary movements or, you know, people straying into the wrong areas is a key area. And so, you know, that's all now on modern rigs automated, so that any unpredicted movement is on the drill floor or the red zone is effectively can trigger, you know, the cease of an operation. So from a safety perspective, this has an enormous impact. And then in a completely different sort of vein, some of our customers are using bot frameworks to aid knowledge transfer. So in theory, if a crew member wants to ask a technical question, he can do so through his computer and get an answer back in you know, the language of his choice. You know, the crews normally come from lots of different nationalities, and traditionally they would have had to, you know, ask the question in the traditional way, and now they have access to the knowledge bank that's stored by the company for whatever it is they might be trying to do, sort of almost at the touch, you know, or at their fingertips. And I guess the final, you know, digital growth vector is digital maintenance. It's a really obvious one, and it's not new, but it's really important. You know, the oil fields sort of moved away from calendar-based maintenance to, you know, to basically condition-based maintenance. And, you know, engineers are now equipped with smart devices, with wearable technology, as well as kind of helmets and spanners, if you will. So predicting these sorts of failures, equipment failures and the like, it obviously saves a lot of money, it increases safety, and it just adds to the overall efficiency of the oil field. So that was a quick summary of some of the things that I see, you know, taking place in our customer base, especially in the offshore sector, which is kind of the focus here. I guess when we ask our customers, you know, how can we help enable their digital programs, I think probably 9 times out of 10 they give us a very simple answer, and that is this: make your network as highly available as possible. If you consider all of the different applications that I've just talked about, and some of my colleagues earlier on have mentioned, yeah, it all counts for naught if there's no connection. In fact, in some cases, operations sort of stop. So it is critical, and it seems like an obvious thing to do. And, you know, as kind of wireless specialists in this industry, we know all about the inherent weaknesses of, you know, frequencies in bad weather or frequencies in good weather, for that matter, with, you know, LTE. And so we've harnessed all of that intelligence, and we've cut our teeth many, many times on getting, you know, the link availability right. But we've in recent years started to use newer technologies like SD-WAN to basically strive for 100% availability on a rig. And, you know, SD-WAN is something that it wasn't used in a widespread way until perhaps last year, and is now sort of going mainstream, especially where there are more than one bearer on board. And even if there is only one, geo bearer, for example, you still might use SD-WAN to virtualize the WAN between antenna A and antenna B. So it's really a technology that's really helped us achieve super high availabilities and effectively answer that question for customers. And the beauty about it, for those of you that know about SD-WAN, is it's intelligent. It's an intelligent path selector, so it allows the best path to be chosen, and we can dictate which application flows through which path, whether it's sensitive to latency, or as a priority situation. So, that's one way, that we keep availabilities really high. And the other thing which we're often accused of, a bit unfairly, is of being a kind of a bottleneck, because the cost of our megabits, in whichever form they take, are generally quite expensive because of where we operate and the systems that we use. And so I think this is where perhaps Speedcast has some secret sauce when it comes to how we actually manage the applications that run over our pipes. We use a variety of tools, including sort of deep packet inspection tools, that mean that we can measure all sorts of packet drops, byte transferals, server response times. And so then when we get a ticket from the IT help desk, which would typically be something like network slow or network's not working, that's about as detailed as it gets, we're able to rapidly go in and forensically analyze what's happened. And in cases where we manage customers' networks, we shut down applications that are offending to cause a wider network disturbance. So it sounds all clever and great and standard, but actually when you consider that some of these drill ships, for example, have maybe 200 people on board, and all of the different systems and applications that that run, it's a very complex environment, and it's all being done on a 3 megabit by 1.5 megabit pipe, for example. And you compare that to being at home with the kids and trying to sort of do a video conference, it is really quite amazing. So yes, a bit of a bottleneck in the fact that we haven't got unlimited speeds to give customers because it's expensive. But actually, it's not so much speed; it's about what you do with that speed and how you manage the performance of your applications. Sort of, it's obvious that the cloud's an important function of the overall digital ecosystem. So we're moving towards the cloud. We're starting to have optical connections into the cloud. We are in another area optimizing Office 365 cloud integration. That's effectively a software as a service acceleration tool that we've pioneered with some of our vendors, and it is ultimately making remote environments like the rig, which is typically not a sweet spot for most IT companies because there aren't that many users. It's allowing them to operate as if they were on the core network on land. So that's there's a lot of value in that. And finally, it's been touched on in previous presentations, about the different types of network on board that are available, and we've invested a lot of time in those different types of networks. Wi-Fi is ubiquitous, but it requires lots of different access points, some of which have to be installed in dangerous areas. So it can get expensive and it can be troublesome. So, an obvious alternative is a private LTE network, where it's available. Sounds easy, potentially single eNode B base station. You can see that you do get very good coverage depending on the frequency used. That's not to everybody's taste, but it certainly works in certain niches of the offshore sector. And especially if companies have, bring your own device policy, or they like to use wearable technologies that have, eSIMs in there. So it all really depends on the customer's need. For others, where people are having to go into the extreme inner parts of the rig, where it's a very complex steel environment. There are other networks that we use that are sorry, interruption there. Other networks that we use to answer these sorts of problems. So we continue to look at the best way to get data flowing around the local area network, as well as concentrating obviously on the wide area network piece. So I think in summary, I see, since I've been talking about the digital oil field probably for the best part of 15 years, that enormous progress. The industry's made a lot of progress. We as a company, Speedcast, have made tremendous progress, and the speeds that are supplying and supporting some drill ships, are now up to 30 megabits of satellite and 30 megabits of LTE combined. So really quite thirsty infrastructures at sea. No, obviously not all are operating at that speed, and nor do they all need to, but those that are really using the digital initiatives are starting to find they need significant amounts of bandwidth. So with that, I'll leave it. Thank you very much.
Thank you, James. Very good. Now, next up, we have Kratos, CEO of Methera Global. Chris's experience includes 21 years at the Ministry of Defence, 9 years as the CEO of VSAT UK, and he currently serves, as I say, as the CEO of Methera Global, whose vision is to provide digital applications to the world's remote and underserved regions through its constellation of MEO satellites.
Hello, I'm Chris McIntosh, CEO of Methera. We're developing a satellite broadband service to deliver huge amounts of capacity in targeted regions of the world, and we can move those targets practically real time. Looking at connected oil fields, firstly. Big question is why? Why digitize oil fields, collection, and the processing operations? Well, I think at a high level, we're looking at reducing costs, sharing, reducing resources, fine-tuning systems, and of course, we want flexibility. When we talk about costs, we need to sweat the assets, the infrastructure, especially given the continual reductions in oil prices, and therefore strive for operational efficiency. And that includes things like ensuring that the most profitable wells are the ones that are being utilised, and switching off assets are just as important as switching them on. As far as fine-tuning these systems, because they are so complex and the decisions and the operating procedures are decided based on the environment and on the current situation, what that means is that you're far better and it's far more powerful to have centralised decision making that takes into account all of the operations that happening globally, as opposed to decisions that are just constrained to the rig or the platform itself. And of course, the availability of low-cost sensors is massively changing, and the fact that you can have sensors of various types, and more importantly, at such a low cost that they actually become the equivalent of throwaways. Therefore, the picture you can build up to actually analyse globally becomes immense. And of course, sharing or reducing resources is paramount. When you think about having lots of resources spread across the globe, if you can centralise them and have the communications to allow them to work effectively, you can dominate and win over your competitors in opposition. And that's predominantly by being more effective and reducing your costs. And of course, we're not just talking about people, we're talking about the systems as well. The expensive and valuable systems that you can hold centrally and that can help you make the decisions and the complex procedures and programs that you need to operate. And what does this all give us? What it gives us overall is an increase in tempo, allowing us to be more flexible, allowing us to move facilities, move resources, and swap and change between what's operational and what's on standby. In essence, It allows us to be extremely more efficient and effective at our primary task. So, what are the capabilities that will support this? Of course, it should come as no surprise that broadband connectivity I see as essential. But things are changing. No longer is it just SCADA systems that provide sensor information. We're now talking about high bandwidth two-way systems that can support complex decision support tools. And what's key about broadband connectivity that can interface directly into other systems is that it allows that inter-system interconnect, allows command and control over a huge number and plethora of systems. Of course, we need dynamic coverage because when you look at the oil industry, it can be anywhere. And so it's really important that we have connectivity when and where it's required. Capacity density is a term that many people wouldn't have heard of. And really, we're talking about the amount of broadband that can be delivered into each square kilometre. And the reason why that's really important given this scenario is that oil fields and the amount of data that they require is so large that being able to deliver a lot of bandwidth to one small area becomes very important to them. And of course, resilience. We need a reliable service that's 24/7 and therefore a number of layers of backup. So let's talk briefly about what's around as far as satellite broadband. MEVRA's competition is generally focused on providing a global service to dispersed customers. They're going after people who need broadband or want connectivity, but they're so remote, or they're nomadic and move in, or they're autonomous vehicles, therefore moving all the time, and they're after the customers who will never be connected to fibre because of the fact they're either remote or constantly moving. And that means, since that's their customer base that they're going after, they design their systems accordingly. So you've got LEOs, where you've got hundreds, if not thousands, of satellites that will be orbiting the Earth, covering the whole globe with a thin veneer of capacity. So in essence, what they're saying is we can cover everywhere, but with not very much broadband connectivity. And with 70% of the Earth being water, I think it's an interesting business case. Then we look at GEOs 36,000 kilometres away from Earth, stationary over the same spot of the Earth, beaming to up to a third of the Earth in one go. Again, the market is very much that they're after things like mobility, whether it be air or maritime, and they're covering a huge area and trying to sweep up those targets as they move. Now, MEVRA, what we're focused on are two main areas: capacity density, because we believe the amount of capacity, amount of broadband that is required and utilised will continue to grow. That means you need to be able to deliver a lot of capacity in a sort of small area. But we also believe that the requirement for satellite broadband will remain transient. In fact, it will become more and more transient over time. Therefore, the requirement will change either geographically or over time. So an area which is a great target for satellite broadband today, in 6 months or 9 months' time, may not be, because, for example, fibre would have reached it. So we've designed a system which is all about providing lots of capacity into small areas of the Earth and then moving those targets practically real time. So we're deploying a constellation initially of 18 satellites, a similar height to the GPS satellites. And like the way you look at, you can see a number of GPS satellites at the same time from Earth. Similarly, we will have a number of satellites that can focus their connectivity on each spot of the Earth all of the time. So in essence, we have multiple satellites targeting each of our target areas, and we can change those target areas dynamically. So we end up with a number of small spots, which are 150 kilometers across, that we can put lots of capacity into, and we can move those spots practically real time to the areas where capacity is required. And we believe that is ideal for the digitized oil field of the future. That gives us a flexible system because we can change the layout as and when we wish. It's dynamic, we can move it practically real time, those target areas. High capacity, multiple satellites serving each area. And of course, that high capacity density gives us we can actually cater for targets which are very close together or very data hungry. We believe we are not broadband anywhere, anytime. It's important to note that's practically the opposite of what our competitors are doing, because they're after broadband everywhere, all the time. So for us, high capacity density in the target areas that are required. And going back to the oil fields and connected oil fields, what we believe, therefore, is that broadband connectivity is key, and that it's the resilience, it's the reliability, it's the flexibility, the capacity density that makes the huge difference. Add to that the requirement for broadband anywhere, anytime, and that leads us to the value for money. And that proposition is what we believe makes Mevera ideally suited to connected oil fields of the future. I'm Chris McIntosh from Mevera. Thank you very much for your time.
And thank you, Chris. Very good. Now, next up, we have Walt Anderson.
Hello.
Oh, excellent, thank you. Now, Walt has created, supported, and/or worked with numerous innovative organisations throughout the world. His mission with Avialto is to build a fleet of solar-powered HAPs, high-altitude platforms, with telecoms payloads, which are stationed in fixed locations, I think 20-25 kilometres above the Earth's surface, designed to complement existing terrestrial and satellite infrastructure to serve the world's remote regions. So, Walt, if you'd like to carry on.
Okay, thank you very much. My name is Walt Anderson. I've been in the telecom business in UK, Europe, Asia, and in developing areas like the United States for many, many years. Run traditional telecom companies. And throughout all that, I was sort of looking at this idea of high altitude platforms as a possible infrastructure provider. We now have a UK company. We are close to the final development stage of building multiple vehicles to provide this infrastructure, similar to satellites, but much lower to the Earth. And so we can provide a much lower latency, and because of the nature of what we're doing, a much lower cost. Here's just a basic design. Each of our vehicles, sitting at around 20,000 meters or 65,000 feet altitude, can see easily a circle of 240 kilometers, 150 miles in diameter, and we can provide spot beam services into those areas or cover the whole area or both. We will be using various frequencies, including reuse of some of the satellite frequencies on a non-interference basis, which will allow us to reuse existing terminals. So the the terminals from NewTek and iDirect could potentially be repointed to a HAP and provide a lower cost, higher quality, low latency service. We have three major business cases, but many other alternatives, and we'll go into that a little later. The reason we can do this now, people say, well, why didn't we do this before? It has to do with materials. The car makers have done an amazing job on batteries. They've reduced the cost of batteries and created a higher density, and that makes a huge difference in building a HAP vehicle. Thin film solar is also an important factor in that it's now very light and very efficient, so that adds value to the HAP. The other thing is the standard materials. A HAP is there are two types of HAPs: aircraft type HAPs, which are very light aircrafts, but they don't stay in one place. Avialto is building an airship type HAP, which can stay in a stationary position in relation to the ground. And so it's a helium-filled vehicle, an airship, that uses very lightweight envelope materials. And now those materials are available, readily available, easy to work with, and we've been able to design something that actually is commercially viable. A few years ago, we couldn't have built something commercially viable that would have worked with the materials available commercially. Now, some people in the satellite industry see us as a potential disruptive competitor, but that's not necessarily true, because we are just one tool in the toolkit of telecommunications. We are not going to be a better option than fiber for certain applications, and there are certain places in the world we'll never cover. So LEOsats, that as Mr. McIntosh mentioned, are very thin, provide a very thin coverage everywhere, are still of value if you're sitting in a very remote area and need to send some kind of communication. You're glad there's a LEOsat overhead. But HAPs provide something unique to certain remote areas. And I give you an example. Indosat in Indonesia has two businesses. They own satellites, geosynchronous satellites, but they also have a big mobile business. They can't afford to use their satellites to provide mobile backhaul because the pricing plans they're providing to their customers in the mobile plans. It just doesn't work. It's not economical for them. And yet the government in Indonesia is pushing them to open vast additional territory and cover millions and millions of more people in the fourth most populous country in the world. So LEOsats aren't going to provide adequate broadband. They don't have enough capacity. Some of these remote areas are not that accessible to add new fiber or microwave links. So a HAP can provide instant on coverage to a vast territories where our service is needed. So we'll put the HAPs where the service is actually needed and link it into the existing fiber networks there. So if your company thinks of itself as a satellite company, we might be a competitive force. But if you think of yourself as a telecom operator and that we're just a tool, we're not. We're just another way to enhance your business, add capacity, and we are a pretty small company, so we're open to partners and working with other vendors in the telecom industry. We began testing in the Black Rock Desert with very small vehicles, and then recently flew a 28-meter, 96-foot vehicle that was certified by the FAA in the Black Rock Desert. We've now moved our entire development operation into the UK, and we've got a pretty good team ready to complete the development and do final testing in the UK before we begin fabricating vehicles in a factory in the UK. We believe there's room for hundreds and hundreds of vehicles. Just another example is the maritime. Most maritime operations offshore, satellite is the only option. We can provide a lower cost, higher quality service than satellites. It's simply a matter of distance and geography. So I found that the best marketing tool ever in all my telecom experience, having a lower cost and better quality service, is the ultimate marketing tool. It is irresistible. And once we get our vehicles in operation where we have that tool, lower cost, better quality, lower latency, it's going to make a huge difference, and we will be able to get a bit of business. This is a map, again, talking about Indonesia. Each circle is 150 miles in diameter, and this would be, if we put a number of vehicles over these various islands, how we provide coverage there. in that area, but we will focus the initial vehicles, since we can only produce a certain number from our factory site initially, on the low-hanging fruit, the places where we have customers that really need service, really want service first, and we'll try to. We're actually looking for partnerships in various industry segments. So the people out there in the oil industry, if you'd like a bit of diversity in your market and would like to have some very interesting technology to lower your telecom cost, if you have operations in places that are now served solely by satellite, we certainly would be open to partnering. There's a final opportunity. We believe we're raising equity now for the final stage of development and to open the factory. And that may be the last equity we ever raise based on operational opportunities of debt financing. So this will be our last equity opportunity as a company, we think, for a while. We're UK based, a lot of partners in the UK. We're working closely with ESA and the UK Space Agency. Strangely enough, ESA and the UK Space Agency consider HAPS as part of their purview. We said, well, it isn't in space, but it's close enough. The other market we see as a big market is the VSAT market. We can replace VSAT capacity transparently. Again, almost in many cases using the same terminal, which doesn't need a movable antenna. So this can be a much lower cost alternative as the oil operators need to increase their data capacity with more equipment and more sophistication. We might be able to reduce the cost while the data capacity gets increased by a significant factor. I don't believe, I'm a space advocate. I've worked in space and aerospace areas, but I don't believe that satellite telecom of any kind can compete with this technology. But we're only in certain places. So for the rest of the world, I'm very happy that satellites are there covering everything. Anyway, thank you very much.
Okay, we are having questions come in. Some of them are specific to particular speakers, and some of them are more kind of catch-all. Now, what I'm going to ask of the panelists, specific to you, if you could just, Walt, I've got one or two for you straight away. So if you could just sit in the room for a second. When I ask a question, I'll mention that it is pretty much for everybody and anybody to field. Panelists, if you could just enter the room if you have got an answer for that question. So just let me start with Walt. You've got two questions from BT, British Telecom, from David Jowsey and Renato Goodfellow. Renato's asking, can FSS frequency bands really be used for HAPS, as you mentioned in the presentation?
Well, we obviously, this is a very sensitive issue, particularly with telecom regulators. So we went to one of the foremost experts in the world, a fellow named Mark Posen, to do a study on this, on interference. And he did a very detailed study outlining the rules and guidelines and power levels that would allow the reuse of satellite frequencies by HAPS without interfering with the existing operators. Now, some governments in the world have already indicated that they might be flexible and give us licenses to operate and prove this capability. Others are obviously still waiting in the wings. But it's obviously very beneficial if you can take a single frequency band and use it many times. You can, the end user, the final beneficiary is the citizens all over the world that need connectivity. So that's why many governments are considering this. So we believe we can do it. We have experts saying we can do it. We have a plan how to do it. And now we just need regulators in each area of the world where we're going to operate to allow us to do it.
All right, good. David Giles is asking, Is HAT station keeping tolerant to poor weather conditions such as high winds?
Well, actually, at 20,000 meters, 65,000 feet, we're way above what we normally think of as weather. Temperature is minus 70 C, minus 55, minus 70 C. The winds are quite benign, which allows us to point into the wind and maintain a stationary position against the winds. Our goal is not to move more than 150 meters from a center point, up, down, or left, right. And with the very benign winds and the conditions there, it's possible to do that. If we were sitting over, let's say, the Caribbean, we could look down on a hurricane but not be affected by that weather because we're so high in the altitude.
Okay, good. All right. Now, if I could ask you to leave the room, I'll explain this. There's only room for 6 people in the room. I'm one, and we've got 6 panelists. Thanks very much, Walt. Right, I'm going to ask a question now that's been submitted from Cairo, from Anadarko Sonatrach. Sonatrach is is actually the Algerian national oil company. Very simple. How will IoT technologies improve the oil and gas industry? Can you all come in and and give an answer to that, please? Hello? Okay, James? Thanks. Should I repeat that?
I think the question was, what's the impact of industrial IoT on the oil field or something of that order?
Yeah, exactly.
So, well, I mean, it's a huge subject, but inevitably, to have a digital oil field, you need to have a means to collect data, and IoT is that means. There are very different types of there are very different ways of collecting the data, obviously, but it's essential really, because without that, then we can't measure the data, and if we can't measure it, then we can't sort of seek to improve it, I guess, at the highest level. So it's quite a vague question and probably a very vague answer, so follow up please if you want to.
Mm-hmm. Chris?
Yeah, I touched upon it in my presentation, and there are a couple of areas that I think are essential. One is the plethora of different forms of sensors that are now available. And when we used to use those in isolation, i.e. locally, of course, decisions could be made that would improve the operation of an individual oil field or an individual search platform. By utilising IoT, not only do these sensors give information back to the platform that they're actually operating on, but now all that information can go back centrally, and therefore processes and decisions can be made at the highest level. So no longer are decisions just made based on information that platform has available to itself. Now the decisions can be made globally across a number of platforms and different things that are going on. So that means that the platforms themselves become more efficient, but more importantly, the whole system becomes more effective and more efficient, because now you're comparing different platforms and different costs across the whole of the environment, as opposed to individual. So I see the use of IoT, in particular sensors and connectivity, drastically improving the efficiency and effectiveness of individual platforms and therefore the system.
Yeah, I'd like to follow on from that and completely agree with it. I spend a lot of time in the upstream oil and gas industry in the UK, and IoT is a game changer for a lot of what we're trying to do in terms of both the construction side of things, in terms of putting the assets in place, as well as the operation and the ability to put considerably more information in the hands of the man on the park, the person on the park, so that they can be more effective, get more done with less downtime, less delay, and less searching for what they need to know. Things like headset-mounted cameras, making a connection back to the onshore organization, is something that we're using extensively in some of the organizations that I'm working with, so that the engineer onshore, when he needs to see something, doesn't have to keep going and asking for pictures or talk to the man offshore. He can just ask the guy who's out on the park to go and look at something, and he can see through his eyes to all intents and purposes. But at the same time, the man that is out on the park has got an augmented reality view of maybe what's inside a valve or a separator or some other piece of process plant. So he knows what's in there, he can see what it's doing. And if he's doing some maintenance work, he can see what impact he's having on that or could have on that. So it's allowing a better crew coordination. And at the end of the day, what that comes down to is more safety, because it means we're unlikely to have incidents where someone opens a valve or closes a valve that causes some kind of high or low pressure situation which could cause harm. So I think IoT is a safety enabler in the long term.
This is another one that, pretty much all of you are in a position to answer. This is from Ian Fraser, IT manager at Stena Drilling. How are you using SD-WAN to deliver end users affordable, faster, and lower latency solutions?
I mean, I can take that one, Paul, or give an opinion, because I did talk about. So hello, Ian. So SD-WAN, we're obviously using it more and more, especially where we've got multiple bearers on board. And so if we have the luxury of an offshore LTE connection, because it's lower latency, it'll be the primary, and VSAT will be reduced as a backup. And the intention is that during periods when that LTE fades, when the weather's nice, effectively, especially in the North Sea and other areas where you get flat sea fade, you can effectively toggle between, switch between, the bearers that are available to you in this case, likely, LTE or VSAT. So if you've got a latency sensitive application, it will route down the LTE, because it has naturally got inherently a lower latency. Mm-hmm. The SD-WAN itself isn't able to reduce latency. It just is an intelligent path selection device to enable the right application to go down the right pipe, as it were. Okay,
good. This one, I'll ask Mark back in the room, because this is cloud specific, and I think he's going to enjoy answering this. It's from Martin Coleman. Now, with the plethora of HTS beams and generally large choice of beam coverage globally, do you think using hot swap services supplied through various beam and different operators in the cloud is the way forward to ensure resilience, reliability, and capacity optimization?
Well, it certainly gives some flexibility in that area. It gives choice. Not only can you put a lot of your infrastructure, your satellite communication ground infrastructure, into the cloud and benefit from the resilience of that cloud infrastructure or that cloud service, you have the ability to switch your service between different antenna, between different teleports, and between different service providers according to the characteristics of your need and the conditions, etc., that are perhaps enabling or denying particular communication services. Of course, whilst you have a great deal of flexibility in your gateway ground systems, you do need some flexibility in your remote terminals as well. If you're switching between different service providers and even different satellites, then you're going to need some flexibility there to be able to point to different services, to be able to jump to different services. A different area of the work that we at Kratos are doing that I didn't discuss today is the ability to dynamically manage remote terminals and have them roam between different service providers, etc. So I guess that plays into the same technique, that we're, through various different approaches, just bringing flexibility to the services that can operate via satellite and allowing those to move around according to the service characteristic or the requirements of the particular service and the resources that are available.
Okay, good. All right. I want to ask Alex to come back in the room now, and also Jean-Michel. Mark, do you mind if I drop you out? Because this is something LTE specific.
Go ahead.
Okay, thanks. Okay, so 1, 2, 3. Yeah, as I say, if Jean-Michel and Alex can drop. Okay, Alex, this is from a gentleman who registered in such a way that it was obvious he wanted to remain anonymous, but I can tell you he's from the Shell Petroleum Development Company of Nigeria. He's asking, can the IQ LTE modem connect with other, and just, sorry, these questions disappear off the page, with other technologies besides Wi-Fi, LTE and VSAT? What's the maximum number of network options that can be deployed to a ship via this intelligent modem?
Let me take this one. I think getting 3 wireless technology on 1 modem is already quite an achievement. The only thing that we do not support is L-band for a mobility perspective, and will definitely require an additional equipment. But our modems do support all the Wi-Fi, LTE, and VSAT connectivity I mentioned. We do work in line with what James said about the SD-WAN future of the organization. We at STE Engineering, we are working on a new generation of platform that will be FD-WAN, built-in SD-WAN and cloud-based, which I think is very important that people understand that SD-WAN not only bring you flexibility, resilience and everything, but it also give you the capability of orchestrating the services rather than orchestrating the data. So you now decide how the service is going to deliver end to end, no matter what bandwidth, what equipment you have. So the modem, this IQ LTE modem, is the first step in that direction. Future modem will integrate maybe fiber optic connectivity, maybe ADSL connectivity, because at the end of the day, SD-WAN is initially built around the internet. So at the current stage, that's the only 3 wireless technology we support, but we are working on more wired technology than wireless. I don't see us integrating L-band as yet in our technology.
Alex?
Yes, Paul. Again, I don't have any information on the specific modem that supports multiple technologies.
Okay. Right, I've got a question here from John McCullum, based in Aberdeen, JM Consultants. He spent 20 years at Baker Hughes, involved in oil field connectivity, as we know. And what he's saying is, just a second, Connected Oilfield, been talking about it for over 15 years. Where are we with it? Which I think gives you pretty good scope to give your opinion.
I think, I'd like to say, I mean, I don't know if you heard the earlier presentations, but in summary, I think we've made great progress as an industry. Things have changed dramatically in that time frame, and it's sort of seismic events in many respects, like events like COVID-19 that will push the agenda even further. Yeah. So I think when we think about the way we work in an oil field today is vastly different from 2 decades ago. So I'd love to hear your opinion because you're very close to it. But from my kind of distant perspective, I think we've made good progress.
Mm-hmm. Anybody else want to address that point?
Yeah, I'd like to jump in. And my biggest concern, of course, is that change is good, but no change is better. And that's mainly because people are just so risk averse in general that when new technologies come along, it always takes far longer for them to be actually brought on board than people expect. But what I believe now, much as what was said just now, is that due to the fact we're now getting connected houses, we're getting connected factories, we're actually moving to the stage where the technologies which we're talking about are becoming routine and normal. Even someone's doorbell is now remote for a lot of people in the UK. Mm-hmm. And what that means is that it's becoming far more normal for us. And I believe that it's the next sort of 5 years where it's really going to take off. Even though, as we know, everyone's searching for efficiencies, sometimes you've got to be brave to actually achieve the efficiencies and the savings that are actually available.
Mm-hmm. Okay.
Also, Paul, I would like to add that as more spectrum becomes available to enterprises, they are going to launch their own dedicated private networks, like we see here in the US on a shared spectrum on CBRS technology. So you will expect more to come with the 5G as well.
Okay, very good. Right, bear with me. Okay, I've got one here from Santiago in Chile, from Ruben Lopez. He's a planning satellite engineer with Telefonica there. How is the state of what is the state of the art in IoT devices for monitoring and value-added purposes? Who'd like to kick off with that?
I can make a stab at that. We only because we have something like 25,000 IoT connections served by satellite at the moment, and that's growing apace. It's a tiny fraction of the overall estate. Maybe most of it is served by cellular, frankly. But there are, even though there are only 25,000 connections in our particular portfolio, we've got about 30 different technologies that we use to address that 25,000. So there is a device out there, if it's using a satellite anyway, that is tailor-made for whichever application you want to do, or if you excuse my vernacular, as near as damn it. So yeah, lots of options. It's a bit of a minefield understanding which one to choose. So I'd recommend you speak to one of our IoT experts who at Speedcast who can save you some time in device selection.
Okay, anybody else want to address that point? No? Okay, let me put another question to you. All right, this is from a gentleman in Bogota. Will 5G replace all other cellular technologies? Does anybody know anything about this?
I can take a pitch on that, Paul. I don't think 5G will replace any technology. Will complement the technologies that we see today.
Well, it strikes me that there are plenty of places in the world where 5G is quite a long way into the future.
Right.
Yeah. Okay, fine.
I would just
Sorry,
add,
can I jump in quickly?
Yeah, go on, carry on.
Can I just add that I
go
would
on.
say not for a very, very, very long time, and after a lot of money has been spent.
Yes.
And all I'd like to add is I live in Dorset, UK, which means that we're lucky if we can get 3G. So if 5G is going to replace anything, I'll be very surprised if it happens in the near future.
Yeah, okay, good. All right, thank you very much, gentlemen. And I'm going to bring this to a close now. Now, the last slide up here is basically my business card. Now, there is a lot of questions here that we just don't have time to answer, but they're very good questions. And what I would like you to do, if you wouldn't mind, is screen save this card, send these questions to me by this email address, and I will ensure that they get to the people that you're actually asking the questions of. because I do want to, extend this dialogue. We've got to work within timeframes here, but I do want to extend this dialogue, as far as I can. So send your questions to me, requests, for contact, and I'll make sure that it gets to the right people. And with that, I'd like to thank our panelists and everybody involved in this. Now, we're going to start up again for session 2 in about 15 minutes. We're just going to set up. You'll receive access information because everybody out there is registered for both sessions. So you probably got one about 45 minutes ago. You're going to get another one in 10 minutes. So you shouldn't have a problem actually accessing the room. And we'll see you all there. And we've got some excellent speakers in the second session as well. Really looking forward to it. So we'll see you in about 15 minutes. We will do our utmost to be on time. And look forward to kicking off with the second session. And thank you once again, panelists, and look forward to working with you again in the near future.